Okay, so this one we're going to talk about naming with transition metals. Okay, so again, this is going to be ionic naming. So if we go back, let's reiterate that we know that everything in group 1 is going to have a +1 charge. Everything in group 2 is a +2. Group 13 is a +3. Group 14 we don't worry about. 15 is a -3. 16 is a -2. 17 is a -1, and we're not going to worry about group 18. So the ones we've neglected are our transition metals, the ones right in here. So these are a little bit easier to figure out what their names are, but we're not able to use our oxidation states that we see up here, okay? So what you got to keep in mind, we're going to use our crisscross rule to help us out. And the reason that we have to do that is because these guys that are our transition metals, sometimes they're going to have a +1, +2, +3, +4, 5, 6 oxidation states, okay? Which is why we don't talk about those a lot, because if we look at something like iron, iron can be a +2 or it can be a +3, okay? Chromium can be a plus, I think it's a 2, 3, 6, and I think there's even a 4 in there. So these are a little bit more difficult for us to do. That's why we don't give you necessarily a rule to do it. We're going to look at the formulas and figure it out based on that. All right, so for the first one, let's say that we have something like the way that these will look is they'll have Roman numerals, okay? So they're going to have Roman numerals. And what these tell us is the Roman numeral equals the oxidation state. Well, sorry, not oxidation state, oxidation number. So for example, if you see something like this that says copper 1 oxide, copper 1 means that we're going to write Cu and we're going to put a 1 plus. Oxide, you guys remember this, comes from, remember this this is oxygen, okay? And so my oxygen is going to be a 2 minus, right? Because it's in group 16. So that when we write this formula now for copper 1 oxide, if I want to know what the formula for that is, I just take my 1, right, and I cross it here, and I take my 2, and I cross it there so that I would get Cu2. Oh, because remember, we don't write, this would be a 1 here. We're not going to write that 1, okay? And so it's very simple. So the reason we have to do this is because there's also a copper 2 oxide, okay? And it's just like what it sounds. So copper 2 means that this is going to end up being Cu2 plus, and this is going to be my 2 minus. So when I take this 2 and I cross it, and I take this 2 and I cross it, I end up with Cu2O2. But remember, I'm going to erase those so that I just end up with CuO. Okay? So just to reiterate this number right here, this is my Roman numeral. This number right here is my Roman numeral, and it tells me the oxidation number, okay? So anytime you see those are your oxidation numbers. You don't have to guess what they are. It tells you right there, okay? So remember, 1 equals 1, right? If you see 2, that's your 2. 3, IV, that's 4. And if we have V, that's 5. And then VI, that's 6. And I don't think you'll see too much more than that. All right, so now we want to look at, well, what if I'm given something like this compound here where it just says Fe 2O3. So how do I know which iron it is? Because remember, what we have to look at is, if we look at iron, iron again is a transition metal. So it's one of your transition metals, so we don't know the oxidation number. We can't look at the top of the group to tell us what it is. So what you have to do is, for these, you have to uncross these numbers. So remember, if you cross them to bring them down, you can uncross them to figure out which oxidation state it is, okay? So we're going to say that this one would be iron. And since that 3 was by the O, remember if we uncross it, that's going to make this be Fe3 plus, and my O would be 2 minus if we uncross those. Remember, the plus always goes first. This is my cation. So it's always going to be a plus with the metal that's first. And my non-metal is going to be the anion, which comes second. That's an Ni there, okay? That's my anion. So in this case, this would be iron. 1, 2, let me erase that, sorry. This would be iron. 1, 2, 3. And this is, again, oxygen, but we change the ending to IDE. All right, so for our next example, we're going to go with COCl2. All right, so CO is not carbon oxygen. This is actually cobalt, okay? And so this is going to be cobalt. But we don't know which cobalt it is. But if you remember, we said we have to uncross. So this is going to come up here. Nothing down there. So that means it has to be a 1. So this is going to be CO2 plus and Cl1 minus. And you can remember that this is a 1 minus also because this is in group 17. And we know that those are always 1 minuses. So that makes this cobalt 2. And then this is chlorine, right? But we changed the ending to IDE, so this is going to be chloride. Okay? So, always to figure out what number is going to be here in the middle, which it's always got to be if this is a transition metal. And how do we know where the transition metals are? Those are the ones in the middle. So if it is a transition metal, you've got to figure out what this Roman numeral here is going to end up being, okay? Now, there are some of them that you don't need to, and I'll show those to you on the next slide. All right, so those that you don't need, you're always going to have zinc is going to be a 2 plus, so you don't have to ever worry about writing anything in Roman numerals. So you don't ever have to do this for zinc, okay? The other one is silver. Silver is always going to be a 1 plus, so instead of writing this, you don't. So if it's in a compound, you would just write something like zinc chloride. Okay, you wouldn't write zinc 2 chloride. You don't do that, okay? Same thing with silver. It's just going to be silver chloride, okay, not silver 1 chloride. Okay, we would never write that. Okay, hopefully this is helpful for you.